Okay, today's lesson is lesson number 95. We're going to be talking about finding distances today. Specifically, we'll be looking at the distance between 2 points as the length of the segment between them. Okay, and we're going to find the distance using the Pythagorean Theorem, which is the topic that we discussed yesterday, okay, in the last lesson. So, let's look at how we do this. Okay, so here's our steps. First thing we're going to look at is the segment vertical or horizontal? Okay, so if it's one of those, all we really have to do is count the units between them. Okay, so we just count up or down or left or right, however many units are in between. And that's our answer. Okay, otherwise, we make a right triangle with the segment that they want us to find as the hypotenuse. Okay, so if the segment is not vertical or horizontal, it must be diagonal. So it either looks like this or it could look like this at any kind of slope, right? Even just a little bit slanted. Okay, if it's something like that, then we make a right triangle. Okay, so you just kind of drop down and over until they meet, and then that kind of like erase the rest, right? Okay, so you just make a right triangle. You could make this one here for this segment, or I could have gone up and then over as well. Sorry. Like that. Okay, so that would work as a right triangle as well. I'd get the same answer, okay? Once you have the right triangle, you're going to count the vertical and the horizontal leg lengths. Okay, so you'll count this. Say this was maybe 1, 2, 3, 4. Maybe this one's 1, 2, 3, 4, 5, 6. Okay, you count those. So now you have 2 side lengths for a right triangle, which means you can use the Pythagorean Theorem to solve for the third. Okay, so with these problems, we're always going to have A and B, and we solve for C. Okay? So let's look at some examples of this. Okay, number 1, this looks like it's just a vertical segment, right? There's no slant here, so I can just count the units. 1, 2, 3, and so my answer is 3 units. Okay, remember when you're counting these, you don't count the original point as well, right? It's just like how many spaces, so 1, 2, 3. Okay, that's how many spaces you are in between, or like how many boxes. Okay. Over here at number 2, this is a diagonal segment now, so I have to make a right triangle. I can make this one in blue, or I could make this one that's in red. Okay, so I'll just use this blue one. I count the horizontal and vertical distances. That's 1, 2, 3 across, and then 1, 2 down. Okay, now this is a right triangle, so this is C. And I plug in these values to the Pythagorean Theorem. So up top I have 3 squared plus 2 squared equals C squared. That gives me 9 plus 4 equals C squared, so 13 equals C squared. I take the square root of both sides, and I get C equals the square root of 13. I want to simplify this radical if I can. In this case I cannot. Okay, there's not a perfect square that goes into 13. 13 is prime, right? So definitely not a perfect square. So I will just write my final answer as the square root of 13. Or I could put rad 13 units. Okay, that would be the distance between those 2 points. In other words, the length of this segment here in red. Okay. Moving on to 3 and 4. If you were absent, though, pause here and make sure you write these down, okay? So looking at 3 and 4, number 3, it's just counting again. Again, when I'm counting, I don't count both the start and the end. Okay, you just count one of them. So if I start here, I go 1, then 2, then 3, 4, 5. Okay, so I get 1, 2, 3, 4, 5 units for number 3. Number 4, I see these are the 2 points. Okay, I gave you the coordinates in case you want to write this accurately in your notes. So you can draw yourself a little grid. That'll make it easier to count the spaces. Okay, so those are the 2 points where these are located. I made the right triangle here. Okay, the side lengths are 2 and 2. right triangle, this side would be C. And I'm going to use the Pythagorean theorem to solve for C now. So I do 2 squared plus 2 squared equals C squared. So 4 plus 4 equals C squared. So I get C equals the square root of 8, which is 4 times 2. And 4 is a perfect square, so that's just 2 squared times 2. This is squared, so it gets to come out of the square root. So I get 2 rad 2 units. Okay, and that would be the length of that segment. Okay, so if the question asked you, what's the length of this segment, that would be your answer. Okay, they could also word it this way. They could say, what's the distance between this point and this point, or what's the distance between the 2 points shown. Okay, any wording like that, your answer is 2 rad 2. Alright, and last couple examples here. Okay, number 5. Again, if you were absent, please try to do these on your own first so you can kind of test yourself and see if you're understanding, okay? But I'll walk through the solution now. Okay, so number 5, this is diagonal, so I need to make a right triangle. Here are the coordinates if you want to sketch it accurately. I can make this right triangle, or I could also consider... here, let me do this a little closer. I could also consider this right triangle up here if I went up and then over. Okay, either way, whatever one makes more sense to you. So the side lengths are 2 and 6. I want to find C. So I use the Pythagorean theorem. That's 2 squared plus 6 squared equals C squared. So 4 plus 36 equals C squared. That gives me 40. And so C equals the square root of 40. I can simplify this as 4 times 10, with 2 squared being able to come out because it's a perfect square. Okay, so I get 2 rad 10 for my final answer here. Okay, and the last one for today, number 6. Okay, I start by making the right triangle. Again, it could be this, or it could also be this one. Okay, whatever one you choose is fine. This is our right triangle, though. I count the distance. This is 4, this is 5. So those are my lengths for A and B. Plugging them into the Pythagorean theorem, I square and then take the sum, right? So I have 16 plus 25 equals C squared. 16 plus 25 gives me 41. I take the square root, and I get my final answer for C. 41 is a prime number, so it only factors as 1 times 41, which isn't very helpful here. Okay, there's no perfect square, so my answer is just the square root of 41. Alright, and that's it for today's lesson. So for homework, you have 8 problems that look like this. So please give those your best shot, and I will see you guys tomorrow. Thanks.